afternoon once again, and you are welcome to this class. So we'll be talking about the exact solution, like I said earlier on, and we'll be looking at exactness of a particular equation and how do we solve them. At what point do we say a particular equation is exact, and at what point do we say it's not exact? So these are the things we'll be discussing this morning. Let me quickly share my screen so that we can go on from there. Can you see my screen?
Yeah, we can see your screen.
Okay. So this is our own. The last class we able to talk about homogeneous and equation. Like I told you, please let's work hard, and from then it will help us exact solution, exact differential equation, differential equation. A differential equation is exact at a particular point. Let's look at it. When you have a differential equation, or we call it okay, let me write this one. The differential equation of m of x comma y dx plus n of x comma y dy. I know this particular one is not that straightforward in your book. Some are tiny, some are big, some are, I know it's, but we can still relate at this level. So we can call this one equation 1. Equation 1, I said, is exact, or is called, let me put it there, is called equation 1 is called an exact differential, I'll use ED now, exact differential equation if there exists a function f of x, you can use capital F, f of x comma y of two real variables such that the expression equals the total equal to the total differential total differential. You remember total differential. When they said we have total differential, we have partial differential from our, let's say we have df, let me just say total differential, df is equals to total differential df. Let's just put this f. So at this point, we are having partial derivative. Anytime you have more than one variable, that's when you use partial derivative. I believe you still remember of dx plus df dy. So in this case, what are the things we need to know? So we have it to be m of s comma y to be equals to the f dx and n of x comma y is the same thing as the f dy. So at this point, what are the things we need to check? If you are asked to check for exactness of a particular problem, how do we do that? Let's look at this theorem. Look at this theorem. The theorem says, that's it, theorem. The differential equation m s comma y dx plus n s comma y dy is equals to 0 is an exact equation if and only if and only if the m, the y, is equals to the n, the x. So it simply means when the two of them are equal, at that time, that's where we say we have exact solution. That is where the function m of s comma y and n of s comma y have continuous first order partial derivative. That is, if you want to prove this one, let's say proof now will be, suppose the equation, let's say equation 1 that we define up, equation 1 is an exact. Equation 1 is an exact differential equation. Then, if it's an exact differential equation, we know that the f, the x, will give us m. And it's the same thing as capital F subscript of x. You know it's differential too. And when you have the f, the y equals to n, which is the same thing as capital Fy. So if I now differentiate my m with respect to y, what happened to it? If I differentiate this one, the m, remember you define the m from, you identify your m and n from the equation you are given, from the problem you are given. Then by the time you now identify them, you now differentiate that m with respect to y, will now be equals to fxy. And you do the same thing, the n, the s, we have it to be fyx. So what we are now saying is, which implies that my f of xy must equals to f of yx before I say I have exact solution. exactness. Let me call it exactness. That shows that we prove this one. Now we'll now look at the example. At what point we check the example of exactness and look at how many we have that is exact, how many we have that does not exact. So in your paper too, they can ask you to test whether this particular equation is exact or not. So let's look at number one to check the example, like I told you. Number one, if you have 2xy, the x plus x squared, the y equals to 0. So in this case, to solve this one, let's m equals to 2xy. Are you getting it? Let m equals to 2xy. And remember from here, from the theorem, that we say that this. So it simply means the m dy. So our the m dy will equals to what? Anybody?
The n dx.
That's 2x.
That's 2x. You have to partially differentiate this. Remember, when you are differentiating in partial form, remember from your knowledge of partial derivative, you are differentiating 2x, you are differentiating 2y. What it simply means is, let me explain. 2x will be a constant. You now differentiate dy over dy. That is the meaning. Are you getting it? So when you are differentiating y now, what do you have? Will be 1, because this is 1. So you have it to be 2x. Let me come again. All this one constant, differentiate this one alone. You know, assuming you are holding 2y constant and you are differentiating x alone, it's still 1. Are you following me now?
Yes, sir.
Okay. So now we have this. So what our n is equals to x squared. So we need to differentiate the n, the x. What is the n, the x?
2x.
2x, correct. 2x. So some of the questions, they can list all those equation in different form and ask you to prove the exact solution, the exactness. It simply means, which implies that the m dy is equals to the n ds. That make this one to be what? To be exact. That's what they ask you to do. That makes it to be exact. Okay, let's try another one. Number 2, let's try this one. 4x sine y dx plus 2x squared cos y dy equals to 0. Our m in this case is what? Anybody?
4x and y.
4x and y. So then, can we now differentiate? Now, in what way you differentiate the m with respect to what?
Dx.
Really? The
y. The y.
You differentiate m with respect to y. You differentiate. Listen, there's no big deal here. Let's look at the general equation. The general equation is here. The first thing you see here is your n. Though you don't need to argue that. And the next thing is your n. You don't need to debate that. Am I communicating, everybody, please? I need your response. Just
Yes, you are. You are communicating, sir.
Yes, sir.
So you can put a chat. If you cannot talk where you are, it's allowed.
sir.
Okay. Any question? Because if you don't get this one, you might not get where we are going. So we need to understand the basic first. So the first one is your M. This is your M. This is my Y. And this is my N. So once you identify these two, you can solve any problem. All you need to do is to brush up your differentiation skill. If you know that you are the type that you don't care about your differentiation, this is where we will know. So please, you have to brush it up and you have to do it right. So how do we differentiate this? The M, the Y. Anybody? When you differentiate sign, what do you have? Sign X, when you differentiate it is what?
Plus 1.
Yes. So you have it to be 4S cos what? Y.
That's why.
That's all. Please mute yourself in case your background is noisy. Now let's look at the N. Our N equation is what now in this case? 2S squared cos Y. The N with respect to what?
The X.
The S. So when you differentiate X in this case, you hold cos Y constant. What do you have? 4S cos Y. You can see that the two equations are, the two partial derivatives are the same. It's equals to the N, the X, which is exact. But now, everybody, I want you to try this on your own now. Let's try this one, number 3. 3x squared y.
I can't see your screen from my hand.
Is this your phone or network? Can all of you see it, please?
Yes, sir.
Yeah, we can see.
So you have
should
to
log
change
out
your
and log in.
location, please. Change your location and get a good network. So let's differentiate this. Everybody, let's try it.
I'm doing it on our own, right?
Yes, do it on your own now.
Yes, sir.
Is there that?
Is exact, right?
Yes.
Okay, let's wait for the others. You assume it is exact, right? Or you do it. Do you have the same thing, anybody?
No, sir. They are not the same thing, sir.
It is not exact.
They are
Okay.
not exact.
Is it? If you know, okay, let's chat. Let's put it on the chart. If your own is exact, put your result on the chart. Just put exact. If your own is not exact, put is not exact on the chart. Let's see. I'm waiting. Yes, one. Somebody. Who else? Okay. Okay, Benjamin. Bisola, Ibrahim. Okay, who else? Charles, you change your mind?
I have to calm down and look at it very well.
You just have to do that. That's mathematics for you. Okay, let's look at it together. That's why you can see. Yes, thank you, guys. Okay, now, let's look at it now. All you need to do is differentiate this with respect to y. When you are differentiating this with respect to y, you have 3x squared y. So I'm only differentiating y. When I differentiate y, what do I have? 3x squared. Because y will have turned to 0, 1. rather. So now let's differentiate this one with respect to x. I have 3x squared y. So you can see, don't just assume everything they will give you will be exact. You are on your own if you do that. The m, the y is not equals to the n, the x. Therefore, not exact. Please take note of that. So we are moving forward. Let's look at this number 4. 2x we have 2x plus 4y minus 1d. Please mute yourself, except if I ask a question. Plus 4x plus 6y plus 1 dy equals to 0. So in this case, our m is equals to 2x plus 4y minus 1. Then our dm dy is equals to what? When you differentiate this, what do you have?
4, sir.
Yes,
Therefore,
sir.
You have 4. Then let's look at this n. The n is 4x plus 6y plus 1. When you differentiate this one, with
4,
respect to s, what do you
4
have?
again. 4 again.
4.
You can see it's exact. Don't be disturbed by any Bugos equation. Say, oh, how do I go about this now? These people are wicked. They are not wicked. It is you that you need to study so that you will know how to solve some of those problems. So we are going further now. That's step 1. How do we now resolve the exact solution? When they ask you to do the exact solution, at what point? And what are the steps that are involved for exact solution? Let's look at it. The first step is steps. The first thing is to check. Number 1, check that you check exactness, which is the m over the y equals the n over the x. You need to first of all check this one. After you check this one, number 2 is to now identify. Remember, you know your m. Your m is the same thing as the f, the x from onset. You remember from the theorem that I proved, which is the same thing as capital F of x comma y is equals to integral of m dx plus g of y. Anytime I'm integrating with respect to x in partial derivative, in this particular one, you have to add a constant, but it's not going to be a constant. Remember, we assume that all the x will have cancelled, then we add a function of gy. But the same thing happens when you are dealing with n, which is the f, the y, which is f of x comma y. Same thing as n dy plus h of x. So if I choose to use m, if I choose to use n, if I'm using m, I'm going to add y. If I'm using n, I'm going to add x. That is, if I'm integrating with respect to x, I will add y. If anytime I'm integrating with respect to y, I will add x. So please take note of that too. So then the step 3 says, we find our, that is, find the f, the y, which is equals to n, and it will also give us g prime of y. Then we can also find the f of x, which will lead us to m, which also give us h prime of x. Then step 4 is to solve for g prime of y or h prime of x. It depends on either of the two that you are using. After you've done that, step 5 is to find g of y or h of x. How do we do that? By, if I'm finding g of y, it's simply g of y will equals to integral of g prime of y dy. If I'm doing the x, it's going to be h of x will be equals to integral of h prime of x dx. So that's how we do that. Then step 6, we are to replace. Remember, replace g of y or g of x or h of x or h of x in 2. 2 is where? Look at 2. Remember here we add this, we add this. We have to replace this one after you solve everything. So let's continue. 7. Just make sure you equate it to be equals to C plus C or minus C. Equate everything to be equals to C after you've all your solution. Then if you are given 8, if you're given, they can ask you to solve for C, initial value. We are given initial value. If time permits us, we'll talk about it. If given initial value, it simply means you have to substitute initial value, substitute for x, substitute for y, and get your C. That's the meaning of that. So then you can now replace them. So let's look at the example of this kind of equation. We just take them one after the other. Then from then we will have some nice experience. Example what we solved the other time. Example 4. Let's go to 5. Any question, please? Any question?
No, sir.
Okay. Okay, let's look at this. We have an example of 4x minus y dx plus 6y minus x dy equals to 0. Can we show that this is exact? Everybody, please do that. Where the f dx is equals to f of this, which is same thing as m, which is same thing as 4x minus y. So what is going to be my dm dy?
-1.
-1, thank you. So the same thing happened Look at it. We are just showing, we are in step 1 now. The f dy is equals to, why are we using the f dy? You look confused, right? Let me explain. Look at this. We said this is with respect to x. That's why we're using f of x, f subscript x. That is, all this particular f, this is f, the entire system is f. So because the has n, that's why we are differentiating with respect to the x. We say that. So you don't need to bother, oh, is m, is y, which one am I going to use? No, it's just all you need to know is the first time is your m, while the second time is your x. Please take note. So now the f, the y is equals to what? F y, which is same thing as n, which is equals to what? 6y minus x. So you differentiate also to know the exactness, which is equals to what?
-1.
-1. Therefore, we have checked. Therefore, the m, the y is equal to the n, the x, which exact. Now, that is just by the way. Then I cannot go ahead and use any of this in number 2. Is it I go for 1? I go for 2, depends. So I choose to go for m. If I go for m, I'm going to have m equals to integral, don't forget, integral of the f, the x, the capital, the total x, which is equals to integral of 4x minus y dx. 4x minus y dx. Remember, our f of s, y is the same thing as what we are doing now. So we need to integrate this now with respect to x before we now had gy. So let's integrate this one with respect to x. If you integrate this one with respect to x, you have 4x squared over what? 2. Minus what?
That's 0. Will be yx.
Will be what?
Yx. Yx.
xy or ys. Y is going to be xy. Remember, it's not differentiation, so it will not turn to 0. If it's differentiation now, you can say this one is 0. Aha. Plus that particular function of y must be added. Since I'm integrating with respect to x, I will add function of y. If I'm integrating with respect to y, I will add function of x. Please take note of that step. So at this point, I have it to be this year 1, year 2. So I have 2s squared minus xy plus g of y. We can call this one equation 1. So the next thing to do is what? Anybody? Look at your notes. We are the type. Let's look at the note, please. I'm waiting.
Find the y. Find the f over the y.
Yes, the f over the y. That is, we are to integrate this one, this particular equation 1. How do we integrate it? When you integrate, we are to differentiate it partially now. Differentiate, write it down in your notes. Differentiate equation 1 with respect to y. So if you differentiate equation 1 with respect to y, when you differentiate this one is 0, right? Because there's no y. When you differentiate this one, what do you have?
X.
Really?
No, which one? Should be 2x squared. We're differentiating 2x squared minus xy.
Yes. When you differentiate 2x squared, you have 0.
0. Then
Minus
x.
Minus x. Plus what? You have to
Plus G
differentiate
of-
this one. G prime of
G
y.
prime y.
Yes. You have to differentiate it with G prime of y. Now, don't forget that from the step, let me take you back to the step. We said that this differentiation we are using is equals to what? N. Look at it. We said this is equals to N, right? So we are going back to it. Because from day one is N, we used to define it. So we have it to be equals to minus x plus G prime of y is equals to N. So what is our N from definition? Our N is what?
6y minus x.
Substitute it there so that some item can cancel. That is the meaning. So we are going to have minus x plus G prime of y equals to 6y. 6y what? Minus x. You and I know that this one cancel this. Do you agree with me?
Yes, sir.
So we have G prime of y equals to 6y. How do we get gy from here? Equation 2. How do we get gy? You need to delete, we need to get rid of this prime, which is differential, by integrating both sides. Integrate both sides to get g of y. So we have integral of g prime of y dy equals to integral of 6y dy. So when you integrate this side, you have g of y equals to, when you integrate this one, you have 6y squared over 2. Right?
Yes, sir.
Yeah.
Yes, sir.
So you can say plus c, let's say plus c1. So at the end of the day, you have g of y equals to 3y squared plus c1. Any question? So we call this one equation 3. Now, remember we have this equation 1 up. Substitute equation 3 into 1. Substitute. Any question? Equation 3 into equation 1. We have what do we have? Equation 1 is what? Can you call equation 1 from your note, please? Anybody?
2s squared minus xy plus g of y.
2s squared minus xy.
Plus G of y.
What is g of y now? Plus
That's
3y squared plus c1. So everything equals to c. Remember, our f of x, which is equals to, which implies, this implies that 2x squared minus xy plus 3y squared equals to c. That's what they ask you to do. Let's go back to our step. After you remember I told you in step 6. Okay, let's start from here so that you can also relate to what we did now. After we find the exacts, we have our G prime or X prime. We have either of the two. We go for G prime. Then we solve for our G prime by integrating both sides. Okay, we get our G prime by substituting our M or N back to the equation. Then next step is to find the G of Y or S of Y by integrating both sides. Then you replace. After you replace, you equate it to be C, and that's all. That's what we did. Any question? Okay, let's look at this one. Silence means it's okay, right? If your own is not okay, it's better you talk now.
Okay, I look at the equation, where we came from. I was thinking that we should get the equation. If we differentiate this, our solution now, we should get where we came from. That means we should get 4x minus y dx plus 6y minus x dy equals to 0. But it's not exactly like that, because we're having a C1 instead of x. If you look at it, they look alike, but there's a slight difference.
Anyway, this particular one is don't need to trouble yourself for that. All you need just to do is just to find the solution for the y. Find the solution for what they asked you to find the solution for. By the time you get to exam, you will not even remember to check all those things.
Exactly.
Where do you have the time to do that? So, yes.
Like Mr. Ibrahim, you said it's not giving you the same thing, right?
Yeah, that's what I said.
But we used M initially, but we start the equation now. I don't understand.
Example 6. Don't worry. Let's do the next one. You will see what I'm saying. XY squared plus 3x squared dx plus, remember, all these integration differentiation are simple if you are not given too much function. 4y cubed dy equals to 0. Now, from our knowledge, we know that our M is the same thing as the F, the X, right? Are we together?
Yes, sir.
Which is 2xy squared plus 3x squared. What is the M? The X. The M dy rather. Let's differentiate this. The M dy is what?
2x.
4xy.
4xy. Okay. When you differentiate this, 2x squared y plus 4y cubed. The n, the s is equals to what?
4x.
4xy.
Please mute yourself.
So please, can I quickly ask a question here?
Go ahead.
What we are doing here is just to determine whether it's exact or not.
Yes, that's
what if a question that after checking we discover that is not exact? What should we do?
That one will come when they ask you to tell us whether it's exact or not. You just write it's not exact at that point. And if it's not exact, hardly you can't follow that step.
Because I was asking if maybe there may be possibility whereby the question might not be correct, and we're asked to solve.
Be careful. Don't reset question for yourself. Remember, you are not doing paperwork. If you are doing paperwork, it is easier to say that at this level, anyway, let me just put it that way. At this level, if you go and check in your coursework, in your coursework, they said if you check page 68 there, in the course material you have with you, whether it's okay or not, you just have to use them, Page 68, they are asking a question. They said, prove that the following equations are exact and solve them. Can you see difference now? Prove that the following equations are exact and solve them. Some will say verify the integrating factor. Some will say solve the equation. And another will say solve the following equation with respect in different way, the way you can solve them. Are you getting it? So what we need to do is we have the rules and regulations. Those ones that did not have exact solution, there are ways of solving some of them. Those ones with exact solution, there are ways of solving them. Is that okay? Hello? Are you there?
Yes, sir. Yes, sir. I'm okay. Thank you, sir.
Okay. So for this one, all we are testing is it exact? How do we solve? So let's look at this. Now, I can choose to use another form. Look at this. The first one, it was integrated with respect to what? With x. In this case now, let's integrate with respect to y and see what, with y now. So if I'm to integrate with respect to y, I'm going to use the f dy would now be equals to 2x squared y plus 4y cubed. So, which means our capital F comma y is the same thing as integral of 2x squared y plus 4y cubed dy. So let's integrate this one. What do I have? If I integrate this one, what do I have, please? With respect to y, 2x squared y squared over 2 plus 4y4 over 4 plus what now? Who can tell us?
C1
Really?
or C2. I don't know.
Plus
Well, we
G,
take
G of
C2.
y.
Check your step. Plus what?
Plus G of y. G of y.
Really?
G prime y. I don't know.
H of
Prime
x.
X. G
H
of
of
X.
X, H of X.
H of
H
x.
of x plus h of x. Go and check the step again. This cancel this. This go with
Right.
this. Are you getting it now?
That's the
Yes, sir.
Aha. Equals to x squared y squared plus y raised to the power 4 plus h of x. Call this one equation 1. So the next thing is to differentiate with respect to f's. The f, the x. If I'm integrating with differentiating with respect to x, what do I have? 2x y squared. When you differentiate this one with respect to x, what do you have?
0.
Plus 0. Plus what again?
Calculation.
H prime.
Thank you. H prime of x. So it simply means that I'm going to have, don't forget, everything equals to what? M. From here, look at it. It's there. I put it here. M equals to the f dx. So everything now equals to m. So we are going to say that 2xy squared plus h prime of x equals to, what is our m? Somebody should call m for me.
2x squared. 2x squared plus
2xy squared, yes,
3x squared.
plus 3s squared. Thank you. So you see that this one will go with this. If you are solving it and something is not canceling, you have to check again. At that point, some variable will go. We have h prime of x. Please mute yourself. Equals to 3x squared. I need h of x. I don't need h prime. So how do I get it? H of x will be what? Integral of h prime of x dx equals to integral of 3x squared dx. So I have h of x equals to what? 3x squared over 3s what?
3x cubed.
3s cubed over 3 plus c1 or plus whatever you call it when you integrate. This one go with this. So we can say h of x is equal to s cubed plus c1, which is equation 2. So we can substitute equation 2 into equation 1. When you substitute, that is, we are replacing our h of x now in equation 1. So we have f of x comma y equals to
X squared, Y
s squared y squared
plus Y.
plus what?
Y is power.
Plus y4 plus s cubed equals to c. So which implies s squared y squared plus y4 plus s cubed equals to c. Any question? All these functions are very straightforward. What about the ones that are not straightforward? Let's look at one of them, whether we can easily grab them also. So let's say number 7. So we have 1 plus y exponential xy dx plus 2y plus x exponential xy dy equals to 0. So how do we solve this one? Our df dx is equals to what? 1 plus y exponential xy equals to m, right? Then we have the f dy equals to 2y plus s exponential xy, which is n. Okay, let's prove whether we have exact. The f, the m, the y is equals to what? Let's prove it. Anybody?
Is a xy e raised by xy.
Exponential xy plus what?
I said xy exponential xy.
Some of you, I pity you. Look at it very well. This one. this is a product rule. Do you agree with me?
Yeah, yes.
Aha. So you can't say that. This is a product rule where you have UV. So you have to solve this one separately, solve this one separately, then add them together. UV is equals to what? V du dy plus U dv dy. Let's say this is our U, this is our V. So what's going to be the answer? Everybody, please solve it. Because when you differentiate this one, you have 0 already. So let's try it. Who is solving it for us? Anybody? Okay. Let's differentiate y first. I will not solve this in this. Okay, let me solve it in this form. Okay, we have du ds, du dy is equals to 1, right? Dv dy is equals to what? It's the same thing as d dy of xy exponential sy. Differentiate this with respect to y. What do you have? You will have s exponential sy. So now substitute dv, substitute this also into your equation. You have uv equals to, or everything here will now be equals to, what is our v? Our v is what? Exponential sy. Our du dv is what? 1 plus, what is our u? Y. What is our dv dy? S exponential ey. Please take note. You have to be smart with all these questions. They are very tricky. So, any question on that? So, when you differentiate this, you have exponential ey plus xy exponential ey. So, can we try the second one? The n, the x. The n, the x, the first term will be 0. So we use the same method that we use. If you use the same method, you are going to have x, this, plus y, plus x, plus xy, exponential ey. So they are both exact, because this particular one, when I use the same thing, this one, I will differentiate this, this one constant, differentiate this, this one constant, and then, sorry. So, any question, please? Is it clear? Can I move forward, please?
Sir, please come again in this the way you.
This is not calculus class, oh. Guys. You need to go and revise it very well. Now, which one should I come again? Charles, talk.
Dm dy, the partial differentiation of dm dy.
Okay, it's very simple. All you have is y exponential sy. And I'm to differentiate with respect to y. I have y here. I have another y here. So I must hold it, I must differentiate it in product way. That is the simple analysis. So if I'm to differentiate with the product way, then I know this is my u, this is my v. Right?
Yes, yeah.
What is the UV. Give me the definition. Give me the formula.
V U D B D S plus
U
V
dv dy, because we are using y now,
yes, sir.
plus V du dy. That's all. I know my u to be here. My du dv is what? My du dy is equals to what? Differentiate u, everybody, with respect to y.
That's one.
That's one. Then differentiate. I know it's the exponential is the issue. Differentiate v dv dy. Let me explain to you in exponential. Everything in power, bring them down first. Differentiate it. Remain exponential with the power the way it is. Everything in power is this. Xy is the one in power, right? I'm going to differentiate xy with respect to y, right? Then retain what is there. It's like I asked you to differentiate exponential u is u, right? Charles.
Yeah. Yes, sir.
Now differentiate this one now. When I will not differentiate this one with respect to y. If I'm differentiating this with respect to y, I will have x into 1, right? Exponential xy. The final answer will be x exponential sy. And that was what I did. Don't forget, this is the v. Substitute everything back to this equation. What is u? My u is what?
Y.
Y. What is my dv? Is s exponential sy. Plus, what is my v? Exponential sy is my v. What is the u dy? 1. If I'm to write everything out again, what am I going to get? Y. I can write it together, xy exponential xy plus exponential sy. That's all. All I want is exactness. Are you okay with this? Charles?
Yeah.
Okay. So you use the same method to solve this one. Because this is already 0. Use the same method to solve it. By the time you are solving exponential of this one now, it's going to be with respect to x. You are going to have y instead of x now. X will have turned to 1, y will multiply by 1, and that's all. Please, go and visit your calculus. Everybody, thank you for coming. Let's continue, please. Let's quickly solve this one. When you are given to Ibrahim, are you okay with this? Kausara?
I'm okay.
Zola Dauda. Odeleye. Who has again? I've not mentioned their name. There are some guys here too. Except they've disappeared. I can see. Adam. Nathaniel.
Yes,
are you there? Theophilus. Olorunfemi. We have somebody here. Rabiat PC. Okay. Who is Rabiat? Are you there? Thompson. Are you guys there, or you are just logging and let them see I'm there?
I'm here, sir. Something is here, sir.
Okay, no problem. Thank you. Rabiat, can you hear us? Okay. Okay, let's continue. So you can now choose any of these, our method. Which one are you integrating with? Are you integrating with F? Let me use F. Let me say the F, the X. The F, the X. It simply means I'm integrating with respect to X. So I'm going to have 1 plus y exponential xy, which implies f of x comma y is equals to integral of 1 plus y exponential sy. This is another issue, the x rather. You have to integrate it with respect to x now. So if you have to integrate this one with respect to x, how do you get it? If you are not signed in integration, go and brush it up. I will also do my part and see whether you can get it to grab. You and I know that it's more or less that is integrating 1, the x, plus integrating y exponential x, the x. That is what they are saying we should do here. So you use substitution method, where you said this one we know is x. There's no case for that. But in this case now, if you integrate very well, you are going to have plus exponential xy. Do you get it? Or do I need to explain?
No, sir.
So when you integrate very well, you are going to have exponential xy and plus g of y. Remember, we are integrating with this, so we are going to have this. We are integrating with x, so we are going to have something similar like this. Then here you have the f dy is equals to x plus this will contain x, don't forget, please. Where you integrate this one. So you have x exponential xy sorry, I'm coming to that place. We have x plus sy plus g of y. Then differentiate this one with respect to y. So this returns to 0. When you differentiate it with respect to y, you have x xy plus g prime of y. Everything equals to what? N. Don't forget. So in this case, you have x exponential xy plus g prime of y equals to, our n is g2y plus x exponential xy. So this goes with this. So you have g prime of y equals to 2y. So you can go ahead and integrate both sides. When you integrate both sides, what do you have? Integral of g prime of y dy equals to integral of 2y dy. So here we have g of y equals to, let's integrate this one. What do you have? 2y squared over 2 plus c plus c1 or whatever you name it. G of y equals to y squared. So I go back to the equation and substitute. What do I have where I substitute it? I have my f of x comma y to be equals to s plus exponential xy plus y squared plus c. So, which implies s plus exponential xy plus y squared equals to c. That's what they asked you to do. Any question, please? Last but not the least, before I ask you to do some, So let's look at this. Lesson number 8, thereabouts. So we have S cube.
Hello, sir. Sir,
Yes.
can you please scroll down? I mean, scroll up. Like I want to see what is a bit. Okay, yeah, that line.
Please, if you are in this class and you know something is not clear and you keep quiet, I don't know whether you have used YouTube or you ask video that is not clear. It's better you ask question, you raise up your hand so that I can explain.
Yeah, continue, sir.
Okay, so it's different from the slide. So when you have y over x, the x plus y squared plus ln x, the y equals to 0. We need to brush up our skill like I told you. So in this case now, our m or our df, dx is equals to m, which is equals to s cubed plus y over x. So our df dy is the same thing as n equals to y squared plus ln x. So let's differentiate the m, the y. What's the how do we differentiate this? What's the answer? Anybody? Maybe I should call the name. Anybody? You want to try? Edward, do you want to try?
Over x. 1 over x, sir.
How do you do it? It's 1 over x. You don't need anything. It's just 1 over x. Because you only need to differentiate y. And when you differentiate y, you know y is what? 1. Is that okay? So let's take note of that. So when you differentiate our dn, dx now, our dn dx is equals to what?
1 over x as well.
It's 1 over x because anytime you differentiate the ln x, you have 1 over x. That's all. You need to know all these tips. You will see that everything we've been doing is differentiation, integration, differentiation. Only that we need to know them. Integral of x raised to power 3 plus y over x dx. So when you integrate this, what do you have? You have x raised to power 4 over 4 plus, when you integrate this with respect to x, remember y will be here. Integrate 1 over x, what do you have? Ln x. Everything plus gy. Because when you integrate, y is a constant at that point and they are together, you can't separate them. So you have to keep them. So don't forget, this is our f comma y. So in this case, we have the f, the y is going to be the f, the y. Let's integrate with respect, differentiate with respect to y. This will be 0 plus, you have, when you differentiate y, what do you have? You have ln x.
Yes.
Plus what? G prime of y. Everything equals to what? Equals to our n. Because anytime you are differentiating with respect to x is n, y rather. So we have it to be ln x plus g prime of y equals to y squared plus ln x. This cancels this. You have g prime of y equals to y squared. Integrate both sides. We have integral of g prime of y dy equals to integral of y squared dy. At the end of the day, what am I getting? I'm going to get g of y equals to y cubed over 3. Yes, any question? So we'll go back and replace our y, our g rather. So you have, if you replace g very well, you have x over 4 plus y ln x plus y3 equals c. Any question? I believe when you have any question on the exacts, you're supposed to should be able to solve them now. All those questions that we first of all check their exacts, you can also lay your hands on them and go further now that you have the steps. You already checked their exacts, you know their exacts, then you can go ahead and solve them. Take the steps one after the other. Please make sure you solve them because you don't know which one will come. Can I stop sharing?
Yes, sir.
So far, so good. I believe you are able to get one or two things today.
Yes, sir.
We get more than one or two things. So.
Charles,
Yeah.
we are able to get a lot of things. That's good. Rabbi Arts. The person has already left. Okay. So any question? Let's try as much as possible and solve some of those past questions that you have access to. And
Sir, can you please drop the past question in the group, because some of the one we have are not clear. The one I saw you checking the other day, it seems clearer than what we have. So you can just drop it. I will appreciate that, sir.
Okay, no problem. Where is what you promised to send to me yesterday?
Sir, I could not find it though. That's why I've not sent it, sir. I'm still looking for it. I have the past question with me. I don't know if my file deleted it. I don't know. I'm still looking for it. Because I even saw.
Okay, no problem. If you have access to the question, please get it across. Okay, you said the one I'm checking last time was okay. Was clear. Clearer,
Yes,
right?
Yes.
Okay, I would look into it. Okay, but there is a link that you guys can use to download some of the questions. Do you have access to that link?
No, sir.
Or I'm not too sure. I will check the one I have. I will upload it for you guys.
All right.
To practice. So Adams, are you there? Sulaiman. Yes, Charles.
So it's based on most of the assignments we've done. We didn't get feedback, sir.
You told me last time, and I replied your mail. I said, okay, receive. You didn't see receive?
No, I didn't see it.
Oh, okay. I will look into that again.
Something also, I didn't see any reply.
No, I will check. So then at times you can, that one will help. What I can do is you can also check and send me this detail. Okay, the link. Yes, I will look into this. You can also send me the in case I did not respond on time. Please send it to me on WhatsApp. Are you there?
Yes, sir. Yes, sir.
You
Yes,
can
sir.
send it to me on WhatsApp. Just give me your name, then I will take note of that. I believe all of us were on the WhatsApp group.
Yes, yes, we are.
Okay, on the WhatsApp group, I just put it there now for you. The link for the past question. In one of my classes, somebody shared that. Have you seen it on your WhatsApp now?
Yes, sir.
Yeah. So you can get it. Ibrahim, you can also look into that.
All right, sir. Thank you, sir.
You will see, just type, I don't know, those probably somebody own the site.
Obviously. But it's helpful since it contains what we're looking for.
Okay. So I think virtually all the past questions are there for different courses. You can just type your, you said you should subscribe. I don't know whether you need to subscribe. You don't need to subscribe anyway. But just download the question and you leave. As many you can download for different courses you are doing. It will guide you. So once again, I want to